Welcome to the Gardien Group podcast series. The Gardien Group, providing extraordinary solutions to today's exceptional problems.
Hello, and wherever you may be, Todd Coleman here of the Gardien Group, welcoming you to another episode of the Gardien podcast series. Today's podcast will be hosted by Rick Meraw, Gardien's VP of Quality and R&D. Joining him today will be Holger Kern, our Managing Director of Gardien Europe. Today they'll be discussing the Gardien Flying Probe line of flying probe equipment. A lot of information will be gathered here for you, so sit back and relax and let the guys take it away. Go ahead, Rick.
Thank you, Todd, for that intro. I'm excited also to be talking to Holger Kern, our expert in our R&D center in Germany, responsible for the flying probe equipment and various equipment within Gardien itself. Welcome to the podcast, Holger. Can you tell us a little bit about yourself?
Yes, of course. Hello, Rick. Yeah, I'm Holger Kern from the Gardien section in Germany. I'm responsible for the R&Ds and Europe part of the PCB industry. And today we want to discuss a little bit about our flying probe line. And I hope we can make a nice discussion about that.
I'm sure we will, Holger. I'm sure we will. So what can you tell us about the flying probe lineup we have? I guess you're going to start with the lower end machines and work your way up to the most advanced machines we have?
Yeah, that's the way I would go. I would assume we have our lineup started with a low end budget machine where we have basically, assembled in China, where we just use the sources we can get there and just make sure that we have a kind of safety as we have to use it outside of China, that we can use the machine without any high risk. But basically the machine is assembled in China, and it is. And these machines are mainly doable for all kind of standard flying probe work. Depend on resolution and sizes is the selection what we can do. In this case, we have a small size machine, it's 24 by 20, and we have a higher pitch by 8 by 12 mil to be able to make standard test. And so we have here basically a belt-driven system where we have standard parametrics for the electrical measurements from 500 volt up to 100 megohms. This machine would be with no barcode reader and printer and stuff like that because it's a low-end machine. And also we have no function like extra test high pot or 4-wire Kelvin. This would be not available for these machines. And that's the point why we have here a low-end one.
So Holger, this machine, could the customer add a barcode reader or a printer or etc.?
Of course, when the customer wants to add it, yes, he can add barcode printer and barcode reader for that, even foot pattern, stuff like that. Basically, the machine is able to do it, but it would be not in the budget price or in the list price.
What kind of PCB technology would this be able to test?
Yeah, the PCB technology, you mean it's a Windows-based 10 machine?
Yeah, but what about pitch in the board, pad size, and things like that? So how accurate? Because you mentioned a belt-driven system, right?
Yeah, but this is a machine basically made for standard low-end technologies like computers and stuff like that. Or in Germany, I would say for the white material like wash machines and dishwashers and stuff like that. And low-end car industry.
So you're talking about 15 mil pitch, 8 mil pad or something like that? Or what
something like that, yeah.
And then we're moving up here. I see a G50. What can you tell me about a G50?
Well, that is our European-made machine or made in Germany machine, where we have some better accuracy because it's better assembled. Basically, we have here also pad and pitch in the same area, but we are more safe to reach this area with 8 to 12 mils. That's around about 200 to 150 microns. We have here the possibility to go up to 1000 volt That's kind of interesting that you can fulfill here different measurements like an high port function up to 1000 volt when needed. That's not possible with the low-end machine. And also the size is the same. It's also 24 by 20 machine. But the difference here again is it's made in Europe. It is with a different electronic equipped and is including barcode printer and everything what you need to be able to put it in the network that you can make verification and stuff like that. And as you can see,
it's also a belt-driven machine by looks of this.
It's also a belt-driven machine. Yes, that's basically, that's also the point why the price is, let's say, in the low-end budget area, because it's a belt-driven machine. Also here we have the same kind of limits, but it's from the quality standpoint, a different level of machine because it is everything made in Europe and in Germany. And also, again, here we have the high port possibility. We have the possibility to make a 4 via Kelvin measurement and some other external function we can enter this machine, but is not able to be on a Chinese made machine. That's all the price different here. And the G75 is also a machine assembled in Asia, in China. The difference is now we discuss here is a steel based machine with a marble portion inside, and it is a spindle driven machine. And automatically with a spindle driven machine, we have a higher precision, better resolution, and also we have here a bigger size. That's a wrong. And the size is 24 by 20. It's a little bit bigger. It's a little bit bigger as the G50, when I'm not wrong. And also we have the limit here is a 500 volt machine instead of a 1000 volt machine, because it is what we can get directly from the market in China.
So if a customer was to buy this machine, how reliable would this machine? Because you mentioned it comes from China, right? Fully assembled in China.
The difference here is really that how the machine looks like, the functioning, how the machine is working. It's stable, it's good. It is, the machines are working perfectly in China for the people there, though it also would work in Germany or in America for that, because it is a standard built machine. It's a different way to build it. It looks different. It is from the housing way, mainly it's a bit different. It looks not so nice basically, but from the function wise, it is okay.
So I'm guessing that we're attaching our software to this to make this more reliable. Mechanics and the hardware come from China, but I think the software comes from Gardien, does it not?
Yes, that's controlled from our side, because that's the only way how you can make it better and more proof that you have the hand on the software side that you know what the machine is doing. And here also the case is that this kind of equipment is not able to make so a high port or 4 Kelvin things without big change on the machine. That's the reason why we have here started with this also kind of low-end budget machine.
Okay, very good. So what about the drives, the lead screws and the drive motors and things like that? Can you get parts in North America and Europe for these machines?
Yes, of course, because the drives, for example, are from Yaskawa. The spindles are made from THK, so that's not a big issue. That's parts available, sources available for that. That is no question, because this have even the people learned in China.
That looks interesting. The price is very economical, it looks like, for a lead screw machine with excellent software, and it's reliable. That's very interesting.
Yeah, that's the reason why we start that. We have basically with our G80, we are starting in the same ball area, because that is also a machine where we have a steel aluminum-based marble frame there, that we have also spindle driven. We have a higher resolution. We have a bigger size, 28 by 24 inches. We're using here stretching and clamping system that we can have movable top part that we can move up and down the sizes of the panel. And we also can use again here the 1000-volt version because that's our made electronic. And we have again all equipment you need from printer and barcode and stuff like that included, that you have a ready-to-go machine when the machine is on site. And the next page we see basically also then a marble-based machine, basically the same as it looks like on the G75. But again, here we can implement different kind of functions because we have the possibility to add external meters for high pot and for high Kelvin. And also, again, we have the 1000-volt version. We can do internal up to 1000-volt high pot measurements, and also we can add a 4 Kelvin measurement to that. And so, price-wise, it's not so much more different as you can see to the G80 to be also interested for a higher quality machine.
So health and safety wise, like if I was to put this in my PCB factory, like a person couldn't lose their fingers or arm or anything, how safe would it be from OSHA standpoint?
Yeah, when you just put click back to the view of the machine, then we would see there are doors, and these doors are controlled by sensors because we have here a high-speed machine with a high force of pressure when we move the axis. That's the reason that with an open door, the machine is not able to operate because we control the door. The operator needs to close the door. Then we have the safety closed, and then the operator can start to use the machine. And basically, when the operator do everything right, there is no risk, and all is protected by CE, that this machine is safe to operate.
Very, very interesting. Thank you for that, Holger. So what about the G90? What can you tell us about the G90 machine?
At the G90, that's basically our 100% own-made machine. Everything in this machine is made in Germany. And we make this for big sizes. Means the standard machine G90 can do 32 by 32 inches. And we have a high accuracy here because although this machine is made with spindle drive system and all is built together from us and built together that it was working correctly. That's the case why they have made here an universal machine to be able also to add a kind of automation, that what we will see later on in this presentation, because the future would be then machines with automation. That's what we're thinking. So as we can see here on this machine picture, that's an aluminum frame, quite flexible. We have 2 windows and it is really solid built together. We are using German-made servo drives and motors. All mechanics are done in Germany. And the marble we have here is a high precision marble that we are really in level on the machine that we can reach what we want to do with about 2 mil pad sizes and pitches, which is roughly 100 microns. That is really, really small.
I would imagine that machine gets flying. It looks like it really is a flying probe.
Yeah, it's a test size. It's also quite interesting because it's a high-speed machine. And that's the reason why we then also did the same base machine called G90, where we have made a special window system. And also we have here glass scales inside to be sure that we can take out the small limits of a spindle, that we really are on point when we move it to one location, that we are really reached at as we want to do it in the right spot, because we discuss here on an approximately 1 meter driveway with the speed up the probe, slow down the probe, and bring it on place within 50 microns to be able to hit a pad. And that is a big task to do. And this we do fully automatic with a loading device in this case.
You brought up a good point. What about the probes themselves? Because I would imagine they're a little bit of a consumable item, right? I would imagine sometimes they break for various reasons, or the tip maybe wear out a little bit over time. So on your series of machines, what kind of probes are they taking? Each one a different probe?
So basically we have 4 probes pads inside. We always use the same type of probe. There's no different in between left, right, or whatever, or top and bottom. The point here is that, yes, it's a tiny one. It is a tiny part, and we need to have a low pressure here that we make no marks and stuff like that on the PCBs. And yes, this kind of probes can break. It's a consumable basically, but the lifetime is not so bad because we can make a couple of million hits theoretically with this probe before it run out on the plastic self basically. The problem basically is here that all needs to be correct in data and PCB, that we make no wrong movements with it. Small pad and probe needle, because when the PCB is bowed like hell, then the machine is not able to compensate that. And then we may break a probe, for example.
So you're saying that from I think your lowest model was a G45, from G45, and the highest one here is G90, they all take the same probe tip?
Yes.
Okay. And then I think you have another machine here to talk about, some sort of, looks like a G90 with something on the end of it. What is that?
That's basically a loader and an unloader in one, where we can add 50 PCBs, 48 to be correct, to be able to that the machine can run automatically without operator for a certain time to make an inline test. That is basically the part what we see on the right-hand side of this machine. And the important or interesting point is that we can here handle different jobs. Means when the machine is setted, let's say we have here 48 PCBs, so we can divide it by 5 jobs. We can set up the machine for 5 jobs, and the machine would automatically set up to the sizes of PCB and to the program of the job, and would test it fully automatic in and out.
So it's interesting you say in and out. So do you load and unload the PCBs from the same side, or is there something different here? Because it looks like everything's on one side of the machine.
Yes, we load and unload on the same side, and during unload, we would then unload the bad one a little bit further more out and set off the good ones that we see the different. But basically, we would load and unload in this case from one side. Basically, you can also add on the other side an unloader, then we would load from one side and unload to the other side. So we have a completely inline machine.
Ah, interesting. So you can put a unloader or load from one side and unload from the other side. So that almost looks like it brings the product right in line with inline PCB production. So right off the assembly line of manufacturing a PCB right into flying probe. Through flying probe, hopefully most manufacturers have mostly a good yield, so 99% yield, 98% yield, and then it can go straight from there in one continuous path straight to the customer, I guess.
This is the idea behind, right? To have kind of flying probe 0.4, let's say, optimization as it made for the future.
Very nice, very nice. I like where we're going. So this is more or less a picture here. Anybody wanted to watch this, they can go to download the video from our website, or of course go on YouTube and on our channel and download the video. and see the pictures, but it looks like we're looking at a PCB being under test here with the covers off the probe tips, just showing off some test electronics. Yeah. Correct me if I'm wrong.
Here we are. That's right. That's basically how a probe tip and probe head would look like. That we have basically, when you look to the left top picture, you see that we have here approximately 4 mil pad, where we have now the probe tip in front, where we hit the pad, and we see the probe tip itself, the electronic on the probe for the compression control, and also we see then the probe assembly electronic where we make the measurements and have the connection to the main unit. And the red light, what you see on the right bottom picture, that is basically the light of the camera for automatic alignment, that we are able to make an automatic loading for this, that the operator just need to pre-select an alignment point and the machine do the rest.
Okay, so how would you know that the actual probe, because my background's in electrical test, I've been in there for many, many years already, but I always, testing a fixture, you have contact problems, you have faults opens, but I also know that if you don't make contact and you're measuring for a short, for example, and you're not touching the pad, I know you can have test escapes in that case. So what do you do to prevent those?
That is basically one of our advantage, I would guess, in our own made software, because we have the full control about the measurement circuit. Because when we make a measurement, then we know where we are, we know we want to have a contact, and then we would get a kind of signal back. And when we would not get this signal in time as it would inspect it, we know that we have maybe a wrong contact, probe hit somewhere else, then we would get an open, or we have a wrong location, that we are maybe in the wrong spot, that also we would create an open or we'd get an error. And also we control the movements, that we are really sure when we make a measurement, we did a measurement. If we got a result back, when we've not got a result back, then also we can tell, hey, something is wrong.
So that sounds very intelligent. We don't like test escapes in general, right? Every manufacturer wants to make a board that's 99%, 100% yield or 100% yield, right?
Right.
But it's interesting, so that you've got some back-end technology in there to ensure that the probe's actually hitting the pad and you're not going to miss anything. So you're actually doing a full test. Right. So on the lower end machines, is this technology there, like on the G45? Is it there or not there? Because it is a Chinese or Asian built machine.
Yeah, it is an Asian built machine coming from China. Yes. But again, that's our software we have implemented here, and we do the same control to have the same safety for test results. Here, for example, we see our own made Y-axis spindle for an up and down movement, where we have a drive motor and a coupling and a bearing for that, and we have a high precision spindle inside. And on the right-hand side, sorry, we see a meter we can add. In this case, this is a meter for Kelvin, but we are able to make a 4-wire Kelvin measurement with this machine. And that's all made in Germany. Okay, the meter is bought for external.
Very interesting. So it looks like you're putting a special meter in the machine to do your 4-wire Kelvin, maybe high pot or something else as well, right?
Right.
Okay.
Basically, we can then follow the routes of the customer when the customer had some routes, or we would then select the best fit measurement we can get on the market.
Well, Holger, it's been very interesting learning about your flying probe lineup. It looks like it's quite the lineup for a PCB manufacturer. So I want to give you a special thanks, Todd and I, for joining the podcast today. Being our guest explaining, it's been a pleasure learning about their flying probe lines.
You're welcome, Rick. It was a nice meeting with you.
You've been listening to the Gardien podcast on the flying probe lines. Rick and Holger gave you a bunch of information. Hopefully it was beneficial. If you need some more information, drop us a line at info@gardien.com. Once again, that's info@gardien.com. You can also visit our website at www.gardien.com. That's www.gardien.com. Thanks again for listening to this podcast. Look forward to seeing you on our next one. Thank you and have a great day.